the first question, for the first example where we are required to calculate the Jacobian, that is, if f is given to be x square minus 2y and g is given to be x plus y, these two functions are given, so that means x is a function of x and y and g is also a function of x and y, then they are saying, then evaluate del f comma g by del x comma y. So this is the question. So here, according to formula, we know del f comma g by del x comma y, that is equal to the taking the partial derivative of f with respect to x and then the partial derivative of f with respect to y and then the partial derivative of g with respect to x and then the partial derivative of g with respect to y. So for that we first need to calculate this del f by del x. So what would be that? That would be partial derivative of this with respect to x. So that would be 2x, because here y is assumed to be constant, and then the partial derivative of f with respect to y. So that would be minus 2. And again we'll calculate what is the partial derivatives for g. So what would be del g by del x? So that would be equal to 1, and del g by del y, that would again be equal to 1. So we'll substitute the values here. So we have the first value del f by del x as 2x. Here it is equal to minus 2 is 1 and 1. So now you can compute the determinant for this. So it would be equal to 2x plus 2. So this is the determinant. So this is very simple. You just have to know how can you compute the partial derivatives, and then you have to just take the determinant. So now let us see this question. They say if x is equal to r of cos theta and y is equal to r of sin theta, then verify that del of x comma y by del of r comma theta multiplied by del of r comma theta divided by del of x comma y, that is equal to 1. So for these given functions, so here in the solution, let us see, x is given to be a function of r and theta and y is also given to be a function of r and theta. So in order to calculate del x by del y with respect to r theta, the Jacobian of xy with respect to r theta, first of all you should know the formula, that is determinant of del x upon del r, del x upon del theta, and then the determinant of del y by del r, del y by del theta. Now in order to calculate these terms, so you know what is x. X is given to be r cos theta and y is given to be r sin theta. So you will first calculate del x by del r, so that would be equal to cos theta, because theta here is constant, so it will come as such, and then the derivative of r is equal to 1, and then del x by del theta, so that would be equal to minus r sin theta, and then the derivative of y with respect to r, so that would be sin theta, and then the derivative of y with respect to theta, so that would be r cos theta. So now you could substitute all these values here, so you will have cos theta minus r sin theta, and here we have sin theta and r cos theta. So now you can solve this determinant, so it would be r cos square theta plus r sin square theta, so it would be equal to r cos square theta plus sin square theta, that is equal to 1. So we have this to be r. So the Jacobian of x y with respect to r theta, that is equal to r. So now let us calculate this term, Jacobian of r theta with respect to xy. For that you will require the expressions for r and theta in terms of x and y. So what would be these? So because as x is given to be r cos theta and y is given to be r sin theta, Therefore, you could simplify this and you can obtain r to be square root of x square plus y square, and you can obtain theta to be tan inverse y by x. So this is what you have. So now you can calculate del r by del x, and so what would be this? Firstly, you will take the derivative for power, so it would be this, and then the derivative with respect to x, so it would be 2x, and so it would become this 2 and 2 will cancel, so x divided by this quantity. And what is this quantity? This is r, so x by r. And then you can calculate the derivative of r with respect to y. So what would be this? It would again be the derivative for power 1 by 2 square root of x square plus y square, and then the derivative with respect to y. So it would again be y by r. And again you can calculate del theta by del x. So firstly we have to perform the derivative for tan inverse of the angle. So that would be 1 divided by 1 plus angle square. So that is y square by x square, and then the derivative of this angle with respect to x partially. So y will come as such, and the derivative of 1 by x would be minus 1 by x square. So this after simplification would be minus y divided by r square. So you could see this, how this is so. And del theta by del y, what would be this? This would again be the derivative for tan inverse first, so it would be 1 divided by 1 plus y square by x square, and then multiplied by 1 by x, the derivative of y by x with respect to y. So this becomes x by r square. So now you have all the quantities. We are ready to calculate the Jacobian del of r theta with respect to x, y. So firstly let me write down the formula. So it would be determinant of del r by del x, del r by del y, and then del theta by del x, del theta by del y. So we can substitute the values. What is del r by del x? That is x by r. Del r by del y, that is y by r. Del theta by del x, that is minus y by r square, and del theta by del y, that is x by r square. So now we can compute the determinant. So it would be x square r cube plus y square by r cube. So it simplifies and reduces to, so this would become x square plus y square divided by r cube. So this is r square by r cube, so this is equal to 1 by r. So we have the value of this Jacobian of r theta with respect to x, y as 1 by r, and the value of the Jacobian, this is equal to r. So when you multiply these two, you are going to get its value is r, its value is 1 by r, so you are going to get 1 as the final answer. So we have verified whatever was required. So let us now see one more question. The next question, which is given to be, so let me write down its statement. Question 3. If y1 is equal to cos x1, y2 is equal to sin x1 cos x2, and y3 that is equal to sin x1 sin x2 cos x3. So then they are asking find the Jacobian of y1, y2, y3 with respect to x1, x2, x3. So this is the question. So now here y1 is given to be cos of x, y2 is given to be sin of x1 cos of x2, and y3 is given to be sin of x1 sin of x2 cos of x3. So now here you see this y1 is independent of x2, this is x1, right? Yes. So this is independent of x2 and x3, right? And this is independent of x3. So using the property third, we can find the Jacobian of this particular term. Okay, so here we have to calculate the Jacobian of y1, y2, y3 with respect to x1, x2, x3. We'll go by a normal procedure that says, firstly compute the partial derivative of y1 with respect to x1, y1 with respect to x2, y1 with respect to x3, and then y2 with respect to x1, y2 with respect to x2, y2 with respect to x3, and then y3 with respect to x1, y3 with respect to x2, and y3 with respect to x3. So firstly we'll do that. We'll directly write the values here. So what is the derivative partially of y1 with respect to x1? So that would be equal to minus sine x1. And then the derivative of y1 with respect to x2, because it is independent of x2, so this quantity is equal to 0, and with respect to x3, this is also equal to 0. Now what is the derivative of y2 with respect to x1? So with respect to x1, its derivative would be cos x1, and cos x2 would come as such. And then the derivative with respect to x2 of y2, this would be equal to sine x1 will be as such, and then the derivative of cos x2, that would be equal to minus sine x2. And then the derivative for y2 with respect to x3, so that would be equal to 0. For the third term, y3 equal to sine x1 sine x2 cos x3. So y3 is equal to sine x1 sine x2 cos x3. Its derivative with respect to x1, these terms would be treated as constant, so it would be cos x1 into sine x2 into cos x3. And then for the second term, it would be sine x1 cos x2 cos x3, and then for the third term it would be minus sine x1 sine x2 sine x3. So that is what we have, and because this forms a lower triangular matrix, therefore the determinant of this would be equivalent to the product of the diagonal terms. So that means we can write this to be equivalent to minus sine x1 multiplied by sine x1 into minus sine x2, and then multiplied by minus sine x1 sine x2 sine x3. So this is the first diagonal term, this is the second diagonal term, so this is the third diagonal term. So we have 3 minus, so it would be minus, then sine x1 is here, so its power would be sine x1 cube, sine x2 is here 2 times, so it would be sine x2 square and sine x3. So you see, what is this? This is sine cube x1. This was the derivative of y1 with respect to x1. So this is the derivative of y1 with respect to x1, and the second term, this was your first term, so this is equivalent to this. For the second term, this whole term, this was what? This was your del y2 with respect to x2, and for the third term this whole term is equivalent to del y3 with respect to del x3. So here also if you have the formation of this lower triangular matrix or the upper triangular matrix or the diagonal matrix, in that case also you can conclude that the Jacobian that is equivalent to the product of these three terms. So I hope this is clear to